Okie dokie, folks. Sign-in sheet coming around, please make sure you sign in. Okay, the first thing I wanted to do, I'm going to be passing back your exams. I have posted the grades on Blackboard. When I do pass back the exam, the very first thing you'll notice on the back is the number of points that you missed. The second is going to be your grade out of 100, and then if you earn points for being here last Wednesday, that is added to that grade, and that would be the last thing you see. I want to remind some folks that I do drop your lowest exam grade. The problem is this is probably the easiest exam of the semester. For most people, they are going to get tougher. Now, for some, there was just extenuating circumstances, and I get that. For others, we do need to figure out what to do. And so if you scored below a C, probably should find time to come talk to me so that we can figure out what to do. And the reason I say below a C is this course is meant to be a preparatory course for College Chemistry 1 and Fundamental Chemistry. You will not be allowed to take either of those courses unless you make a C or better in this course. So that's why I'm saying if you score below a C on this test, since it is the easiest test of the semester, probably want to get in and have a chat with you at some point so that we can come up with a plan of action to try to make sure the rest of the grades aren't as low. So, and I say that, I think I have to put in about 8 to 10 progress reports and I do it for anybody that has a D or an F in my course. Those are the ones I put on in because again, you have to have a C or better to go on to the next course in my class. So if you're on my list, you may get contacted by your advisor, and that's why. Any questions? I also wanted to remind you because some folks, so when I was putting in the grades and sending it in on the progress report, some folks may have had a C average, but right now it's listed as a D average because they forgot to do some quizzes and homeworks. Some folks, and so that brought their grade down from what might have been a C down lower. So again, that's why I'm saying anybody that did not do or is not doing well, we really need to talk and come up with a plan of action. Because we've got to get on top of things in order to make sure that this is a jolt to the system, and then we can get you back on track. Speaking of quizzes, there is a quiz that's due today. It is over ionic compounds and polyatomic ions, if I recall correctly. And there is a homework that is due tomorrow at 11:59 p.m. Now, right now, if you look at Blackboard, I think you're going to see all of your grades. I've tried to get everything up to date, including a column that is bonus. And that bonus is based off of what I saw on Qualtrics. So if you did the career survey and you don't see bonus points, you need to come see me because there were a few names where it was just the first name. And I tried to match it up, but I wasn't always successful. So if you think you have those points, you can come see me. Any questions before I pass back exams? Okay. And hopefully I do not butcher names today. Connor Bisk. James Bull. Connor. James Bull. Ashton Casey. Lisette Childress. No, ma'am. Say, be nice. You be nice. You're coming over here to me. You're gonna come over here to me. Maybe easier to come this way. She didn't seem to have as much objections. Sydney Chukwanu. Eric Didier. Sydney Dunlap. Jakia Ferris. Jakaya. I knew I was going to say it wrong. Ugh. Jordan Fetter. Brianne Jin. Destiny Grant. Harrison Hall. Lauren Hall. Michaela Hardwick. Krista Harper. Ashlyn Hevner. Jaquan Harvey. Brady Johnson. Kanias Johnson. Amia Jones. Tahia Kabir. Olivia Maines. Iman Malik. Catherine Martin. Riley Miller. Rachel Nelson. Julia Norwood. Kaylin Oswald. Rachel Peterson. Amanda Ray. My mind has gone blank. I know it's Riddle. His last name. Isabel Rose. Taylor Ross. A Raven Solman. Mason Simpson. Ashia Smith. Lexi Sanche. Okay. I will leave this up here, and if people did not sign in, because I know some of the names are here that did a group did not get it. Okay. I will try to get the key posted tomorrow so you can check the key out. I just did not get it done today yet. Okay, I did try to give partial credit on everything I could. So the front page, everything was worth 1 point. Every little square that you had to add something was worth 1 point. On page 2, the top, and I'm going to go over this one because I think it's probably the most missed section. They were only worth 1 point apiece for that table. But when I'm looking for responsibility, the responsibility of the protons is the identity of the atom. The responsibility of the neutrons is the isotope of the atom. And the responsibility of the electrons is the reactivity of the atom. I think that's probably the most missed question on the entire exam, as far as a single set of questions missed. The next part was worth 1 point each as well. Then you get into your electron configurations, which were all worth 5 points apiece. Then you get into the metalloids on the periodic table. And folks, you got to know who they are to know who's a metal and who's a non-metal, because metals are to the left, non-metals are to the right. The metalloids are boron, element 5, silicon, element 14, germanium, element number 32, arsenic, element number 33, antimony, element number 51, tellurium, element number 52. And if you gave me polonium and astatine, I gave you credit. Though they are, though depending upon what book, what you look at, they vary depending on those two elements as to whether they'll call them a metalloid or not. But I get, those were each box was worth a half a point each, but at the same time, I did have spare points. So if you started putting in things that weren't metalloids, it went against you too. So you could have gotten all the metalloids, but if you put in things that weren't metalloids, that would count against you as well. Page 4, the alkaline metals are your group 1 metals, and you do not list hydrogen. Hydrogen's not a metal. It is a non-metal. Your halogens is group 17. Folks, you've got to know those names, because especially with halogens, we don't refer to them. A lot of times we'll say the halides. And if we say the halides, we're talking about the anion because of IDE. We're talking about the anion of group 17. On page 5, the non-metals were to the right of those metalloids I just listed out earlier, and hydrogen. You had to include hydrogen. For number 13, Your group is the column, the period is the row. So the answer should have been molybdenum. And then finally, your transition metals are group 3 through 12 on the periodic table. You got to know your terminology. It's not just sufficient to be able to do the math and stuff. You got to know the terminology. Any questions before I move on into today's material? You get to keep them. I don't want I don't take my tests back. Any questions for me? Okay, then if there are no questions, so we've talked about the exam reminder. You've got so many homeworks you get to drop. You got so many exams, or one exam you'll get to drop. You've got quizzes you will get to drop. Now, when I should say one more thing about the progress reports that I had to turn in. Again, if you have an, right at this point, I don't know what to drop. So those grades that I had turned in are, include everything. So if you have some zeros in there, it's likely those will get dropped, but again, I won't know until the end. So right now they're included in the grade. So letting you know that for future reference. Okay. Well, if there are no questions about that, again, reminder, you have a quiz due today. It's over what we went over on Wednesday of last week. Last week, what we specifically focused on were the combining of a cation and an anion to form an ionic compound. And we took the formula of the cation and the formula of the anion, and we developed the formula of the ionic compound. We also took the names of ionic compounds and learned to translate those names into the formulas of ionic compounds. So Wednesday of last week, the entire focus was on the development of the formula of an ionic compound. What we're going to be doing today is we're going to be going in the reverse direction. We're going to take the formula of the ionic compound and we're going to get to the name. That is going to be the more challenging of the processes. Once we finish that, we will start getting into covalent molecules. The very first thing I'm going to do is describe the difference between a covalent molecule and an ionic compound. And then after I finish with that, we'll get into actually the formulas and names of a variety of covalent molecules that I break down into 4 groups: diatomic elements, halogens with group 7, hydrogen with group 15 through 17, nonmetals and metalloids, the alkanes, and the binary covalents. And then on Wednesday, we're going to finish up whatever I don't get to today, and then we'll discuss acids. Now, folks, I would say naming is probably names to formulas and formulas to names. It's probably going to be about 60% of your next exam. And they are either right or they are wrong. I can't give partial credit. So just be warned, it's going to be around 60%. The names to formulas and formulas to names of compounds is going to be roughly 60% of the next exam. Normally, what that means is that would be about 30 questions right there, because they're normally 2 points apiece. But the big issue is they're right or they are wrong. And I'm not trying to scare you, but you have about 2 weeks before the next exam. So I'm trying to put you on your guard so you can start prepping for that. There are lots of optional homework. And there's one optional homework that is mixed formulas and mixed names. Before you go into the exam, those mixed formulas and mixed names are going to be probably the best set of exercises, because it's going to be like it is on the exam, where everything gets mixed up. As I've been introducing it, I've been introducing it by type: ionic compounds, diatomics, this, that. But that's not how it comes up on the exam. It comes up in a mixed format. So that mixed formula to name, mixed name to formula worksheets are going to be extremely useful, that are in the optional homework folder. Questions before I get started? Okay, so at this point, let's get into our information. And why are you misbehaving? Because you want to, apparently. Okay. So when we developed the formula of a compound from its name, one thing I made note of is that the cation was always listed first, followed by the anion. Now, one aspect that is important to know when we get into the names is that it doesn't matter whether we're dealing with an anion of an element or whether we're dealing with a polyatomic anion. The formulas and the charges are a constant. For that reason, if it's an anion of an element, when we name it, it's going to get the ending IDE. When it's an anion of a polyatomic, it's typically going to be an 8 or an ite. So in other words, the last word in our formula is going to end in either IDE, ATE, or ITE. The anion is actually pretty straightforward. It is the cation that can be the challenge, because in your journey to name the cation, you have to ask yourself a question. And that question is, does the metal always have the same charge? Or I should say, does the cation technically? So that means it would be in group 1,
Group 2, silver, cadmium, zinc, and aluminum, gallium, or indium. If it is one of these, then the answer is yes. So you simply name the metal. If it is not one of these, that's where it's more tricky. Because if you'll remember, those transition metals, the majority of the transition metals and the metals that were the larger in size in group 13 through 18, those metals can have more than one charge, and we have to represent that charge with a Roman numeral. So if it's not one of these, then you need to determine the Roman numeral. Now to do so, there you can actually use an equation. The equation you can use is that the Roman numeral is determined as the number of metal cations times, give it could be any variable, plus the number of anions times the anion charge and we're going to set that equal to 0. So again, we can determine what the Roman numeral is by solving the equation. It's the number of metal cations times any variable you want to give it, plus the number of anions times the anion charge is equal to 0. So let's look at this and get into these problems. Let's say I have lithium and oxygen. I'm looking at my cation. And the first thing I'm going to ask about the cation is that metal one of these? Yes, because that metal's a group 1. So since that metal was a group 1, we're simply going to name the metal. So that's going to be lithium. The second part of the name is the anion. We're talking about an anion of an element because it only has the one element there. So what is the ending for all anions of elements? Ide. So this is oxide. So Li2O is lithium oxide. Let's look at another one. Let's look at this compound. BA open parentheses, NO subscript 3, close parentheses, subscript 2. So once again, we go through the question process. We're talking our cation. Is that metal, is it a metal that always has the same charge? Yes, because barium, Ba, is in group 2. And group 2 always has the same charge. So that means we're going to name the metal. So this would be barium. And then the anion. This is a polyatomic anion. It is a period 2 polyatomic ion. When I call it a period 2, I'm talking the non-oxygen atom. The non-oxygen atom is in period 2. The non-oxygen atom in period 2, if there are 3 oxygens attached to it, it's going to get the ending 8. So this is nitrate. So that is barium nitrate. Let's look at another one. Let's look at MnSO4. MnSO4. So folks, I'm going to do the same thing I've been doing. The first thing I'm doing is I'm looking at my cation. And as my cation, I'm asking, is it one of these metals that always has the same charge? In this case, the answer is no. Since it is not, we've got to determine what the Roman numeral is going to be. Now, I gave you a drawn out formula, but I can do it a little bit easier than that. According to this, we have one metal, and we're going to give it a Y for its charge. How many sulfates are there? Sulfate is SO4. Sulfate itself is all of it, SO4. So it's just one. Remember, if there's more than one polyatomic, we got to put it in parentheses. So since there's no parentheses, there's only one. And what charge does sulfate normally carry? I heard it, I think. -2. So you can write out the formula, but in my opinion, it's easier to go, okay, I have one times Y. So that's one. Come on. Thank you. So that's 1Y. I have 1 times the -2. So that is a -2. And I am going to set that equal to 0. Yes. It means that there are 2 nitrates because of barium's 2+ charge, but when naming it, we don't have to worry about it. Because it's the only reason we have to worry about this formula is if the metal is not group 1, group 2, or one of those. That's the only time we have to worry about the formula to get the Roman numeral. Sulfate is that it as a unit, sulfate is always SO42-. This is sulfate. That's just its formula every day of the week. The way I kind of keep in mind that it's a -2 to help me keep that in my head. If I asked you what the charge on sulfur would be, what would you say? It's the same. No, it's okay. What if?
It doesn't add up, even though it's got oxygen too.
No, because again, it's the entire unit is a -2. So this entire piece is a -2, not just the oxygens, not just the sulfur, but the entire piece. Okay, so once we solve for this, we get a Y of 2. So this one we would have to name as manganese 2 sulfate. Just as a reminder, in last week's folder, there is the full list of polyatomics once again. Yes, that. And there's also the periodic table that shows you the relationships of the polyatomics, which if you'll review that, it really does start to help. Okay, let's look at another example, and then we're going to do several. We'll look at 2 more examples. So we're going to look at Ag3PO4 first. Again, we always start from the same perspective of looking at our cation. Does the metal have the same charge? In other words, is it one of these? Yes. So since that's the case, we simply are going to name the metal. And name the anion. So this will be silver phosphate. Looking at the other one, we have PB, open parentheses, SO4, close parentheses, 2. We always start with our cation. Is the metal we're dealing with one of these? No. So that means you're going to have to determine the Roman numeral. So we can take our lead, we have one of those, we're just gonna give it some random variable. It could be Z, it can be Y, it can be L, it can be whatever you love. Just give it a variable. And then sulfate. Again, folks, SO4 always comes with a 2- charge. So this is a 2- charge. Now, in developing our formula, we have 1 times Z, that's supposed to be a Z. And we have 2 times the -2. And that's equal to 0. So Z minus 4 is equal to 0, Z equals 4. That is your Roman numeral that you just determined. So this is lead 4 sulfate. So I use this specifically as a comparison here. Both of these, you will notice that the sulfate was a -2. The only difference is because there was no parentheses around the sulfate and manganese 2 sulfate, that meant there was only one of them. But this parentheses tells me there's 2 SO4s. Literally, folks, what this formula is telling me is I have a PB4 plus and I have 2 SO4 2 minuses. That's what it's telling me. Questions? Ite means that, okay, so this comes back down to your polyatomics. So SO4 2- is sulfate. SO3 2- is sulfite. So it becomes ite when you lose an oxygen. And sulfite, folks, just like sulfate is always SO4 2-, sulfite is always SO3 2-. So it's only got 3 oxygens. Again, it's important that you start memorizing those polyatomics if you haven't already. Don't forget, there's also a Quizlet last week that gives you all the polyatomics to help you. Okay, let's do some practice. I'm going to shut up for a minute and walk around and let you work on some of these. So let me come up with some formulas here. CO. First one is C little case O. You need to walk around. You want to walk around? Huh? We have to walk around. Or you gonna just like it? Pepper. You're being obstinate. Come, let's walk around a little. See if we can. Okay, so looking at the board or screen, questions about the answers. So COS is cobalt 2 sulfide. The cobalt had to have a 2+ charge in order to counterbalance the sulfide's -2 charge. Al open parentheses C2H3O2 close parentheses 3 is aluminum acetate. Mg open parentheses Cn close parentheses 2 is magnesium cyanide. CD3P2 is cadmium phosphide. BaCl2 is barium chloride, and Zr open parentheses OH close parentheses 4 is zirconium 4 hydroxide. Probably one of the most missed things is going to be related, one of the most common mistakes I see is I will get here, people will give me cobalt 1 sulfide because they're going, oh, there's only 1 sulfur. But remember, this is nothing, it doesn't have anything to do with how many of each atom there is. It has to do with the charge on it. So you've got to figure out what that charge is. The second most common thing that's mistake is going to be right here. Cadmium is one of the 6 in the stair step that always has the same charge. And so it does not need a Roman numeral. Questions about those answers? Okay, then we're going to move on to covalence. So the molecules we've talked about so far are ionic compounds. Ionic compounds, if you'll recall, contain a cation and an anion. That are attracted to one another. Like magnets. This can occur, or I should say a cation and an anion can form. As long as the energy necessary is a reasonable amount. I'm not really going to ask you what a reasonable amount of energy is at this point. All I'm trying to get at is, for instance, the non-metals cannot form cations. Too much energy is required to make a cation, a positive, out of a non-metal. It is just not favorable with respect to energy. So it's not likely to occur. So the energy is the driving force behind whether whether ions can actually form. Now, I wanted to bring that up in order to explain the difference between an ionic compound and that of a covalent compound. Covalent compounds contain covalent bonds. Covalent bonds arise through the sharing of electrons between two atomic nuclei. So nobody gains an electron, nobody loses an electron. And it is simply a lot more energy efficient for these elements to make a covalent bond than to make ionic bonds. So what are the elements in a covalent bond? Covalent bonds consist of nonmetals and metalloids only. I told you the terminology is important. So what do I do when I have a formula or a name? The first thing I ask myself, first thing when I look at a formula or I look at a name, first thing I ask myself, what type of element is listed first? Is it a metal? That means it's ionic. And so we use the naming and formula we've been talking about. Or is it a non-metal metalloid? If the first element listed is a non-metal or metalloid, that means it's covalent. And we're going to use the methods we're about to discuss for naming those. So that is the very first question that comes off my mind to try to sort these. Metal, ionic. Non-metal metalloid first, covalent. That will help you to figure out which direction you want to head in naming these things. And again, a covalent compound consists of a covalent bond, which is the sharing of electrons. It shares the electrons because that is energetically favorable. It can be done, in other words. So there are 4 types of covalent compounds we're going to talk about. The very first one we're going to talk about is actually elements. Its keys are rattling. Okay. There are 7 elements. That are found in pairs in nature. I'll show you 2 ways to memorize them. Those 7 elements, method number 1, you can memorize the term Brinkelhoff. If I can get it right. Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. When they are alone in nature, all by their little lonesome, when you've got a molecule of, or when you've got oxygen in nature, it's always going to be in the form of O2. When you have chlorine in nature, it's going to be Cl2. Now, that is not true once we get it into a compound. That is when it's all by its little lonesome. Once it gets into a compound, we can have different quantities of chlorine. We can have different quantities of oxygen. It's only if it's all by its little lonesome, it doesn't come in pairs. So method number 1 is to remember Brinkelhoff. Method number 2, told y'all the periodic table is a wonder. So I said that there are 7 elements. They form the number 7 on the periodic table, and then you have to add hydrogen. So that's another way to memorize it. They form a 7 on the periodic table, and then you have to add hydrogen. Take your pick which one you like. And you may know of another way to memorize them. But that's 2 ways. So basically, folks, this is their formula. Their name is simply bromine. If I say I have bromine, I have Br2. If I say I have iodine, I have I2. If I say I have oxygen, I have O2. So in other words, when we have the name of the element as presented on the periodic table, what we are describing is a diatomic element for all of these. That's the first version of naming and formulas. The second type of covalent molecule we'll mention are going to be is going to be hydrogen with group 15 to 17. Okay. First of all, let's talk formulas. If I asked you what the charge on group 15 nonmetals is, what would you say? Negative, -3. The formula, when you combine hydrogen with a group 15, is going to have 3 hydrogens. When I ask you, what is the charge on group 16? -2. The formula is going to have 2 hydrogens. And if it's group 17, it's a -1, so it's going to have 1 hydrogen. Now, to name these, that's their formula. That's all there is to the formula, folks. The number of hydrogens is equal to the charge we've been talking about. Now, this is a covalent molecule because it's nonmetals and metalloids only. But still, we can use that same thought process of 3-, so 3 hydrogens to help us out. Now, naming them. You are going to say the word hydrogen, followed by the name of the second element. With the ending "ide." The only exception to this rule, and I will count you wrong if you do it, that exception is H2O, and H2O is always water. But otherwise, besides water, for instance, this one, you're going to name the hydrogen, and then you're going to name the second element, but give it the ending "ide." So this would be hydrogen nitride. You name the hydrogen. Then you look at the second element and give it the ending "ide," hydrogen phosphide. You name the hydrogen. And then you look at the second element and give it the ending "ide," so hydrogen fluoride. When you have hydrogen, again, we're talking covalent molecules here. We're talking nonmetals and metalloids only here. That's the key. We're talking nonmetals and metalloids only. When you have hydrogen with a group 15, 16, or 17 nonmetal, it's a matter of the number of hydrogens in the formula is equal to what the charge would be if it were an anion. And the second thing is it's hydrogen followed by the main name with the ending "ide." With that, we'll pick up with alkanes and binary covalent acids on Thursday. There is a Quizlet for diatomics. There is a Quizlet for the hydrogen with group 16 and or 15, 16, 17, I think. And then there's a Quizlet for alkanes and acids, which we'll get to. I will see you on Wednesday.